there are three different statements in the assembly language. The first one is directive, like global start, section.text, section.data. The others are operations like add, sub, CMP4 compare, even though we use CMP to implement something like if else, but we explained that what the CMP does is just a simple subtraction, but the output or the result that which flags get set or reset, it's what the jump would look at, and then somehow we implement the if else. It's the jump which controls the flow of data. So the third group would be those instructions which are for controlling the flow of data, like call, return, jump, move, and so on. So we could somehow say the instructions in the assembly language are either an operation or some instruction for controlling the flow of data, right? On the other hand, we know that we could convert all the operations to add. We explained in the first module that we could convert a multiplication to addition. We could convert a subtraction to addition. We could convert division to subtraction, and therefore to the addition. We could convert all the operations to simple additions. Also, what I'm going to say in here is that we could convert all the other instructions for controlling the flow of data to move. So just look at this program, which was the password.nasm, and we created a couple of lectures ago. Just look at it how it goes. First, we have a couple of move instructions, then we get to the syscall. Just forget about syscall for now. Then we get to jump exit. What jump exit does is that it moves an address of which the exit is pointing to into the RIP register. It just gets the address of the exit and puts it in the RIP register. So jump, the unconditional jump, is just a move instruction. Then we get to move again. Move, syscall, move, syscall again. We get to load effective address, which, if you notice, it's again another move. It moves the address that the MGH pass is pointing to inside the RSI register. Again, LEA, it's another move. Then we get to compare, which, as I said, is just a subtraction, or we could convert it to some addition. So what we could say about this compare, for example, we could say that because it is a subtraction between the RDI and RSI, we could say, for example, add RDI and minus RSI. Again, everything that I say is just I want to create some mapping for you, but eventually we know that the compare is just simple addition. The JZ, again, it would be another move, a move of the print success label in here, the address of this label inside the RIP register. We get to decrement, which is another addition. When I say addition, I mean the subtraction, which we could convert it to the addition. And again, we get to another jump, which is also another move. So if you notice, everything that we are doing in here is either a move or an add, a move or an addition. Also about the syscalls in here, this is a write system call, and then we get to the read system call. Also, if I press Ctrl Shift and T and use the S trace to see all the system calls which are run when we want to execute our password process, and if we hit enter, the first system call which is invoked is execv for loading the process into the memory. Then we get the write system call, which we implemented in here, and then we get to the read system call, which in the read system call we should type something in here, and eventually we see that we have 4 different system calls: write, execv, write, read, and exit in here. Now these system calls have been implemented using C. If we go to this website, thebootlin.com, we could see all the source code of execv, read, write, or all the other system calls. And if you notice, for example, execv, the latest version is about or this is actually the open system call. The execv is, I think, about more than 2,000 lines of codes. But if we get the process of execv, we somehow compile and link it, or we look at the process which is the implementation of exec or the open system call, and we use the objdump as we did for the password. For example, objdump in here -m intel -d. I don't know if we could just say exec ve in here. No, we don't have any such file. So What I mean is that, let me just use the password in here, and this was the disassembly of all the code. We could just use the put the execve, the related process for execve or other kind of processes, and eventually we would see that all they are made of are the same thing that we are seeing in here. If they have call, well, we know that call and return are just some jumping, right? But eventually we know that all of them are either move or some simple addition. What I'm trying to say in here is that any computer which could do a move and an add could do any other thing. In another word, any solvable, any computationally solvable problem could be solved using a computer which could only do the addition and moving. This is called a Turing complete machine, which is able to solve any computational problem with just moving and addition. It would be just a Turing complete machine.